Welcome to lecture 2 of CS407 Distributed Computing. My name is Jyotsna, faculty in Department of Computer Science, Rajagiri School of Engineering and Technology. Today we will be focusing on the characteristics, design issues and challenges in distributed systems. Design issues or challenges in designing the distributed systems includes transparency, heterogeneity, openness, scalability, reliability or fault tolerance, flexibility, security, concurrency, and emulation of existing operating systems. The designers of distributed system must take care into account these things while designing a distributed computing environment. These issues or challenges in designing the distributed systems, these are also some other characteristic distributed systems other than the characteristics which I mentioned in lecture 1. Let's look at each of the challenges in designing a distributed system one by one. The first one is transparency. The transparency is concealment from the user and the application programs of the separation of components in the distributed system so that users perceive the system as a whole rather than as a collection of independent components. You know the definition of distributed system, right? The distributed system should appear to its users as a single coherent system. The question here is how to achieve this single system image. The design issue is to hide from the users the fact that processes and resources are physically distributed across the network, right? Only if a single system image is achieved, then we can tell that the system designers have achieved transparency. So transparency is to conceal from the user and the application program the separation of components in the distributed system. There are 8 forms of transparency: access transparency, location transparency, replication transparency, failure transparency, migration or mobility transparency, concurrency transparency, performance transparency, and scaling transparency. Let's look at these 8 forms of transparencies. First one, access transparency, enables local and remote resources to be accessed using identical operations. That means access transparency allows user to operate shared resources as if these shared resources were on their own computer. Next is location transparency, enables resources to be accessed without knowledge of their physical or network location. Replication transparency enables multiple instances of resources to be used to increase reliability and performance without knowledge of the replicas by users or application programmers. Failure transparency enables the concealment of faults, allowing users and application programs to complete their task despite the failure of hardware or software components. Mobility transparency allows the movement of resources and clients within a system without affecting the operations of users or programs. Next is performance transparency. It allows the system to be reconfigured to improve performance as load vary. Scaling transparency allows the system and the applications to expand in scale without change the system structure or application algorithms. Concurrency transparency enables several processes to operate concurrently using shared resources without interfere between them. Next challenge of distributed system is heterogeneity. Heterogeneity means variety. In distributed system we can apply heterogeneity to all of the following: networks, computer hardware, operating system, programming languages, implementation by different developers. In distributed computing, many computers nodes are involved. They may be in different networks. They may use different hardware, operating systems, programming languages, and implementation by applications by different developers. You can see the difference in all of these areas. In order to mask these differences, in distributed system, common standards for communication network and the representation of primitive data items and data structure in messages these are agreed and adopted for the programs by different developers to communicate with one another. For example, Internet consists of many different sorts of networks. Their differences are masked by the fact that all computers attached to them use the IP to communicate with one another. Mainly in distributed system, middleware layer is responsible for masking the heterogeneity of the system. To assist the development of distributed applications, the distributed systems are often organized to have a separate layer of software that is logically placed on top of the respective operating system of the computers that are part of the system. This organization is known as middleware. Middleware is actually a set of softwares. It's a software layer that provides resource management, facilities for inter-application communication, security services, and for masking and recovery from failures. Next design issue is openness. The openness of a computer system is the characteristic that determines whether the system can be extended and re-implemented in various ways. That is, the degree to which new resource sharing services can be added and be made available for use by a variety of client programs. Openness can be achieved only when the specification and documentation of the key software interfaces of the components of a system are made available to software developers. For example, RFC, request for comments, specification of Internet communication protocols and applications that run over them. Another example is W3C, World Wide Web Consortium, develops and publishes standards related to the working of the web. The challenge to designers is to tackle the complexity of distributed systems consisting of many components engineered by different people. To summarize, open systems are characterized by the fact that their key interfaces are published. Open distributed systems are based on the provision of a uniform communication mechanism and published interfaces to shared resources. In open distributed systems, the conformance of each component to the published standard must be carefully tested and verified if the system is to work correctly. Next challenge or design issue of distributed system is scalability. A distributed system is described as scalable if it will remain effective when there is a significant increase in the number of resources and number of users. Some principles for designing scalable distributed systems are to avoid the centralized components. For example, avoiding centralized entity like a single mail server for all users. Avoid centralized algorithms like a single online telephone book for every client. Also, perform most of the operations on client workstations. These principles will help the system to be a scalable system. The design of scalable systems presents the following challenges: controlling the cost of physical resources, controlling the performance loss, preventing software resources running out, avoiding performance bottlenecks. Controlling the cost of physical resources means as the demand for a resource grows, it should be possible to extend the system at reasonable cost to meet it. Controlling the performance loss. For a system to be scalable, efficient algorithms are to be used to achieve the minimum performance loss. For preventing the software resources running out like the IP addresses in the internet. Avoiding performance bottlenecks. Algorithms should be decentralized to avoid the performance bottleneck. Some shared resources are accessed very frequently. For example, many users may access a web page causing a decline in performance. The fifth characteristic and a challenge of distributed system is reliability and failure handling. A distributed system is reliable only if it can avoid fault, it can tolerate fault, able to detect and recover from fault. In the domain of network and server, how the dealing with the partial failures is really a challenge. Some techniques for failure handling are: the first one, detecting failures. Failure detection means the use of hardware and software mechanisms to determine the occurrence of failure and to correct the system to a state acceptable for a continued operation. For example, you might have studied about checksums in computer networks. Checksums can be used to detect corrupted data in a message or a file. The second technique is masking failures. Some failures that have been detected can be hidden or made less severe. For example, two examples of hiding failures are: the first one, the message can be retransmitted when they fail to arrive. The data, the file data can be, if it is written in a pair of disks, if one is corrupted, other may still be correct. The third technique for failure handling is tolerating failures. Some clients are designed to tolerate failures. For example, when a web browser cannot contact a web server, it does not make the user wait forever. While it keeps on trying, it informs the user about the problem, leaving them free to try again later. A service, another service used in it's the main technique used in distributed system for fault tolerance is redundancy. The fourth technique for failure handling is recovery failures. Recovery involves the design of software so that the state of permanent data can be recovered or rolled back after a server has crashed. The fifth technique is redundancy in hardware and software. Service redundancy means keeping the replicas in more than one system. The redundancy can be made available by the use of redundant components. The sixth design issue and a characteristic of a distributed system is flexibility. Flexibility involves two things: ease of modification and ease of enhancement. Ease of modification means it should be easy to incorporate changes in the system in a user transparent manner or with minimum interruption caused to the users. Ease of enhancement means it should be easy to add new resources to the system. The design factors that influence flexibility involves using the object-oriented programming approaches to increase the functionalities. Another method is using the microlithic kernel instead of monolithic kernel. The seventh challenge or a characteristic of distributed system is security. The security of information resources has three components: confidentiality, which means protection against disclosure to unauthorized individuals; integrity, protection against alteration or corruption; availability, protection against failure and always being accessible. So security involves these three things: confidentiality, integrity, and availability. And cryptography is the non-practical method which deals with security aspects of distributed system. The eighth characteristic of a distributed system and a challenge of distributed system is concurrency. If a process that manages a shared resource take only one client request at a time, this approach limits throughput. Therefore, services and applications generally allow multiple client requests to be processed concurrently. In distributed system, each resource is encapsulated as an object and the invocations are executed in concurrent threads. For an object to be safe in a concurrent environment, its operation must be synchronized in such a way that its data remains consistent. This can be achieved by standard techniques such as semaphores, which can be used in most operating systems. The ninth characteristic or design issue of distributed system is emulation of existing operating system. For commercial success, it is very important that a newly designed operating system must be able to emulate existing operating system. So with this, I am winding up today's class. Let's summarize. Distributed system is a collection of independent entities that cooperate to solve a problem that cannot be individually solved, right? And these independent entities communicate by means of message passing over a communication network. In order to get the advantages of the distributed system, the designers of distributed system must take into consideration the key design issues and characteristics such as transparency, reliability, flexibility, performance, scalability, heterogeneity, openness, security, all these, while setting up a distributed computing environment, right? So thank you for listening. Hope to see you on lecture 3.